皆さん、こんにちは。私はフイです。Great thanks for having me to making this presentation about Linux distro state update on RISC-V. It's been half years since I made the similar presentation in RISC-V Day Tokyo 2021 autumn. There are some good news and update on Fedora on RISC-V, which I wanted to share with you. Okay, so please allow me to start my presentation. Okay, in this 30 minutes, I will summarize the latest Fedora 36 on RISC-V, including current support software, how we make it, and some simple steps describe how to run Fedora on QML, and what is our plan for the next step. Then I will also showing about current status for some other Linux distro on RISC-V, like Arch Linux, Gen 2, and so on. Finally, I will provide some current status of firmware and kernel development status on RISC-V. So let me start with our major topic, Fedora 36 on RISC-V. As you may know, Fedora 36 has just released, aka G8. We start our Fedora 36 building after RISC-V Day Tokyo 2021, the autumn. We start to build Fedora RPM packages using Fedora's 36 branch of SRPM report in Fedora 33 environment. In another word, we are building Fedora 36 from Fedora 33. And it's a big leap, but we have to do that. We make some problem, and we spend a lot of time to totally kick Fedora 33 from 36 and using 36 repo independently. So here we still have to great thanks to the people who made the foundation work of Fedora on RISC-V, like DJ, Richard Jones, Davey, etc. Without their hard work, without their work on Fedora 36, we cannot make Fedora. Without their hard work on Fedora 33 and the previous version, we cannot make this happen so faster. But for now, Fedora 33 is dated. If we wanted to make Fedora RISC-V become an official support Arch in Fedora, we need to make it up to date, follow the RUHI branch of Fedora's SRPM report. So at the end of last year, we decided to start with the latest release of Fedora, which is 36. I and my colleague Ocean Liu took nearly 4 months hard work to build Fedora 36. In 4 months, we nearly built more than 4,000 packages at a time. But now, for now, we have built more than 14,400 SRPM. Expressively, maybe more than 65% of all Fedora SRPM. Is a huge report, and we can base on this report to enable a lot of different functions. We keep on making more and more new package every day. Try to make a big enough repo to do massive rebuild, which is we don't have to worry about dependency, and all the package can be built automatically in Koji system. Now we are working on moving all the package to the public host. Can be downloaded by anyone. This host provided by Chinese Academy of Science. Our latest imaging and RPNs will be there in this month. So since Kuma is the most convenient and available target for every developer, so in Fedora 36 environment, we are using libvirt and Kuma as our test target and tools. So Kuma is natively supported by our imaging. We will post a new wiki page in Fedora Wiki talking about how to try Fedora 36 imaging with libvirt very soon. So the documentation is ready. We just need to post in the wiki page. So in this slide, you can see the desktop environment running in the Kuma with libvirt. And this is some screenshot of our imaging running on Kuma. We have Sugar desktop. You may think this very familiar because it's Sugar desktop is using in OLPC long time ago. And we also support LXQT desktop. That means we already built enough library for Qt environment. So some of the people ask me if we can support Qt on Fedora. Right now, my answer is yes, definitely, because a lot of embedded system and also the car vehicle OS need Qt support. So we already make it. We can support this in Fedora 36. We also make some lightweight Fedora desktop environment supported, like LXDE and XFCE, which has been supported. So we have made all this environment for testing. They work well now. But for now, we have some problem on LLVM pipeline, which is about the default driver for the 3D or something. So we cannot test the Genoa desktop on Kuma, but we are trying to test it on Sci-Fi Unmatched. We are waiting for a good platform for Fedora workstation imaging testing, like with graphic card and GPU in it. And good hardware still our blocker for the rich OS development. But we do have some good news. Like after JH7100 from Starfight, which is a silicon company in China, only working on RISC-V silicon. So they have made a new silicon called JH7110, which they have mentioned it in last RISC-V summit in US. We will working on that and enable Fedora 36 and all kind of a desktop on it. So you will see the desktop environment I mentioned will be on this platform development board called Vision 5 V2 very soon. Since this is since there is embedded GPU and PCIe Gen 2, so it could be a very good laptop prototype for RISC-V. Not just that, and we also have some other upcoming and existing platform can be used, like Sci-Fi Unmatched, Sci-Fi Unleashed, Ovin D1, Canon Camdraft K5110, K10, and Polarfire Icicle Kit, and some upcoming hardware like BeagleBoard has mentioned they will have 2 RISC-V development board in this year. So I'm looking forward to that. And Chinese Academy of Science is working on their PC and server level open source RISC-V core called Xiangshan. So actually they have made one silicon and it's worked well, and I'm looking forward to their second generation and third generation, because maybe in the third generation we will have more and more hardware, server and PC level PC level device in the silicon. So we have a lot of work to do to make Fedora 36 support all these platforms. So talking about these platforms, I forget to share about the real running Kuma to you. So let me just show a little bit the real Kuma. So now this is the LXDE software environment, and you can see we also made Pigeon running, and it connects to the network. It really can be a usable tool for our work. So this is the Fedora 36 workstation edition. We are enable LXDE, and we have very good file management window, and also a lot of different tools for internet, and also we built transmission for download, and a lot of different system tools like gparted. You can check all the things, all the hardware, partition there. So yeah, okay, let's just a show for our LXDE imagine. And then now let's talk about how we build a Fedora 36. We're still using Koji for the RPM building, but all the builder are Kuma. Since we got a good enough server, so Kuma is still the most powerful builder for now. And so thanks to the help from Chinese Academy of Science, we got several powerful servers from their cloud service, and we have more than 72 builder in the server, and we can build thousands of packages a day. But we also need some extra help, like user mode mock builder, because Koji builder is using system mode, so it's kind of a slow sound of a large package. We still need 1 or 2 days to build. So, but the user mode on x86 server can be more and more faster than Koji system. So sometimes we are enable some user mode to help to build some large package, just accelerate our build. But user mode still have some problems. Sometimes they have some you will get some stranger problem, like call dump or section 4 for some building. But if you move this build into the Koji, it works fine. So user mode and system mode are the two major tool we are using. They helped each other and accelerate our work. So for now, that's our main build architecture for now. So that's all the things I want to talk about for Fedora 66 for RISC-V. And the next part is about other Linux distribution on RISC-V. First of all, I want to introduce the Gen 2 imaging. Gen 2 distro. Gen 2 is a very good distro which build all the package natively in their own environment. So for now, they have the bootable imaging and enable most of environment like Geno. They told me Geno works. Geno desktop environment works, and most of environment desktop environment has been supported. And also they have made Firefox and Chrome works, it seems. So Gen 2 is the will support operation system for RISC-V. And the Chrome OS is maintained and developed by the RIOS in China. It's a RIOS lab in China. One of the several engineer is working on it. They already made a good root FS, and they are testing the booting. So, and Arch Linux is the huge is a very good distribution for RISC-V right now, and they not just building the bootable imaging. They are also helping other also helping other OS developer like me. Sometimes I talked with their maintainer and get more help for some cutting edge package. Like today, we are building Firefox, and they already have Firefox version 100 being built. So they have patch. So we kind of taking some patch from them and building a package for Fedora. So I have to say great thanks to all the help and all the help from Arch Linux maintainer. And Debian distro is the well supported distro since RISC-V has support by Linux. So still in maintenance, and some of the people I still wanted to use in Debian. So it's a good reason because it's well supported by from upstream. And OpenEura is the open source community in China, start by Huawei, and they already making the bootable imaging for Qma, for D1, and also for Starfire Vision 5. They enable XFCE desktop environment recently, and so Olo is start from Fedora 29, but you already have a branch from that and maintained by themselves. So it's the it's a wire maintained distro for RISC-V right now. And also we may have Android OS very soon by the hard work from Hat from Alibaba Group. They already made a demo last year in the RISC-V conference in Shanghai last year. So I think Android is ready for the Hat silicon. They already have a new platform called C910, and the development board is on the way. So I'm very looking forward to good development board by including the C910 IP core. So other distributions also support RISC-V, like OpenWRT, Buildroot, and Yocto is why you well use RISC-V, well use embeds OS, which I think is the first first OS support Geno on RISC-V, which has been great thanks to Davy, who has made a lot of help to Fedora, but he also made Geno running on RISC-V. Great thanks to him. So for now, we have a lot of operation system, and the software ecosystem is very good support RISC-V, but we still need more hardware, some more good high-level silicon to support our software. So looking forward to your new hardware, and I'm if you have a good software like you can just like a PC or laptop, please contact with me. While we are very pleased, it's our pleasure to make Fedora and other software, other distribution running on that. So the last part is software component. For now, because of the time limit, I will go through it very quick. Like SBI, OpenSBI will support RISC-V, and you can the main branch and the genetic platform is encouraged to use on every different platform. Because if you have a good DTB and no patch required for most of the platform, you can directly use OpenSBI. Like the platform I'm using, the demo I just showed is using the latest OpenSBI, and we also have U-boot support, upstream U-boot support. Most of the platform just need very little patch can enable U-boot on their platform. And GNOME has been most of a GNOME patch and feature. Most of a GNU, most of a GRUB patch has been upstream, and I already made GRUB imaging can running on RISC-V, booting by U-boot. So, and the Linux kernel work well on RISC-V. So the current boot flow for Fedora on for Linux on RISC-V is the firmware developed by the silicon vendor, and then the firmware will boot OpenSBI, which is the FW dynamic.bin, and then this bin file will boot the U-boot bin, and the U-boot may boot GRUB. They can boot GRUB, and GRUB will loading the GRUB GRUB configuration to boot Linux distribution. That's the standard boot flow for Linux on RISC-V. And in the coming future, we will enable UEFI for RISC-V. So actually, this is on the way, and the engineer from HPE and the engineer from Western Digital, they are working very hard on UEFI support and ACPI support. Last year in the Linux primer, they have shown the ACPI work with UEFI, booting up the RISC-V QMO system. So I think this is not a problem for not a blocker for RISC-V server in the future, and it is quite the status of that is quite well. So thank you all the people who helping me on this slide and who give me enough information to making this happen. Great thanks, and thank you very much.